Hey gang, welcome and thanks for joining us today to Akridata's webinar here. My name is Chris McBride from Akridata. I'll be your host for the next 30 minutes. I also have one of my colleagues here that'll be doing most of the work here today. It's Alex Berkovich, who is our principal AI ML engineer here at Akridata. Before we get into this, this is the first of a series of monthly webinars. We'll be exploring topics focused on improving the quality of the visual data that we're using for training your computer vision models. Now, our topic today, as you can see on the screen, is a data-centric approach for preparing data for computer vision models. In our next session that we're doing in about a month, so keep an eye out for that invite. We focused on troubleshooting model errors and how you can quickly build new training sets to address these errors. So for the next 30 minutes, we're going to really go through a quick short presentation. And then most of the time is going to be focused on demonstration on how to use Akridata's Data Explorer to take a data-centric approach for preparing data for training computer vision models. And Alex is going to show you how to use Data Explorer to do a few things. First is just to perform a visual data tally of the embeddings and the images. I want to say this is everything you're going to see today is done on unlabeled data. But that visual tally will help identify outliers in your data set, help with bias detection within the data set, and give you a good basic overall understanding of the data set. Then we're going to demonstrate how the automatic clustering of the unlabeled images allows you to easily explore the makeup of the data set, and then show search and advanced search features that allow you to quickly build high quality training sets for your training model. And that can either be on new sets of data, or you can, if you have one large data set, you can reuse that data set to select a new set of images for training or for potentially a new model. Once we're done with the short demonstration, we'll have a quick Q&A. And if you have questions, go ahead and type them into the little Q&A icon down at the bottom of the screen, and we'll answer them at the end of the session. We're going to keep this moving along. I promise we'll wrap it up in about 30 minutes. And we will share the recorded link with you at the end of the session. And feel free to share this with your colleagues or anyone you think might find it useful. So with that, let me introduce Alex Berkovich, who's principal AI ML engineer here at Akridata, to get this thing rolling. And Alex, the floor is yours.
Thank you, Chris. Hello, everyone. So let me start with a few words about Akridata. We're about 4 years old, and our first product, the Edge Data Platform, is about working with large volumes of information coming from edge devices. But today we're going to focus on Data Explorer. The current product is a platform for every computer vision practitioner to focus on the data first. Focus on the data, and as Chris mentioned, there are many challenges when we work with different data for computer vision models. So we'll see how Data Explorer handles those. I've been in computer vision for over 15 years, and I can honestly say that I wish I had Data Explorer throughout my career with different projects. So let's get straight into it. What is the data? What is the data's life cycle? Obviously, based on the different project and product statements, we're going to start with acquisition. Now, we deploy different sensors. It could be cameras, it could be IR sensors, X-ray. And based on those sensors, we're going to start acquiring images, footage from different sources. And we always remember to put some aside for further testing. Now, while we do all these not trivial parts of the flow, there are different technical questions we always ask ourselves. Do we have enough examples? Do they cover all the corner cases? Are they diverse? How do we get new examples? And if we get new examples, are they good? Should we use them? Finally, once we've trained a model or developed a certain algorithm, we ask ourselves, why did it fail in some cases? Typically, these technical questions, they come hand in hand with the challenges. So how do we keep image quality? How do we keep the entire data set with relevant high quality? And how do we remove things that we don't want within the data set? Outliers, images of low quality, things that shouldn't be there. How will we find if the data set is balanced, whether or not we have diversity within each cluster, diversity between clusters. Interestingly, once we have a lot of information, we may want to reuse that one for different projects. How do we do that relatively easily? So it all comes down to quality and quantity of the data that we have to start well and to build the best applications based on the highest quality of data. So to curate that information takes a lot of time and a lot of money. Now, that's not even the end of it. Once we have a first reusable data set, we start developing the algorithms, we start training the models, testing them, and we have the feedback loop of how we can improve the quality of the data and quality and accuracy of the results. Now, this is where Data Explorer comes in handy. Our goal is to make the building of the data set step as intuitive and as quick as possible. We want even the split between the train and test parts is far from trivial. We can't have leakages. We don't want to fool ourselves. Otherwise, the performance in the lab won't be as the performance on in production sites. We want to have everything done quickly, obviously, and we want to minimize the number of training cycles. We want to make the feedback loop as effective as possible, and we'll see how we can do that with Data Explorer. Now, we spoke about quantity, quality. Data Explorer allows us to immediately identify outliers, immediately identify things that shouldn't be in the data set. But on the other hand, if we have a large data set, we can easily find examples that otherwise would have taken a lot of man hours to find. We can compare different subsets to maintain the data quality of the entire data set. And overall, I want us to be able to operate and manage our visual data set as efficiently and on the highest level as possible. Now, before jumping into the live demo, one word on how we represent the data set. So each image is processed, it's represented with a certain feature vector, and then we cluster based on those vectors. Now, if we do the work well, the first two examples in this slide should be clustered into one cluster, and the third image, the one at the bottom, should be in another one. That's the basic flow of Data Explorer. And now, without any more slides, to the real thing.
Alex, let me do one thing. I'm gonna throw a quick poll out there for a second that I'd ask the gang just to take a look at, and it's really trying to identify the top challenges that you guys are dealing with. So if you could do that real quickly, and Alex, go ahead, back at you.
Thank you. While you're completing the poll, let me share the other part of my screen. And Chris, once we're happy, we can continue.
Yeah, go ahead and roll. We're good.
Awesome. So this is what Data Explorer shows by visualizing a data set. On the left-hand side, we can see a visualization of about 1,600 images. And on the right-hand side, we can see one of these clusters. What do we see? As mentioned previously with the simple example, each image was in some way processed. Each image was represented in some way, and then we did clustering based on that representation. Now, this is a demo, so we did our own featurizer, but we support bringing custom-made featurizers as well. Now, in this case, we see 7 different clusters. The purple one contains natural images, whereas this one contains X-ray. I have IR here. I have different flavors of surfaces. And I have satellite imagery. So the idea here is to demonstrate how Data Explorer will tackle completely different sets of images, process them, and cluster them. Now we have several different clustering options available to us, and that immediately should provide us with a lot of useful insights into the data. First of all, we can immediately identify outliers. We can immediately identify and remove images that shouldn't be. If we have images of low quality, they should be clustered together and we can remove them. That's number one. Number two, we can focus on the images that are relevant. Obviously, this is a toy example. No one will create a data set combining of such different types of images. But in the next couple of examples, I'll show you how this visualization can be used to focus on the relevant subset. But before that, a few words about infrastructure. So we start with the notion of a container, which is where all the data is stored, and we work with all cloud providers, or the data could be local. Now, these are examples of a few S3 buckets, and each S3 bucket can contain multiple different projects. For that, we have a notion of a data set. This is a set of different data sets, and each data set contains both the images and the metadata associated with it. So, as an example, as we're talking about this one, we can look at the most basic information that it contains. So it contains file path, file name, and pretty much nothing else. This is the most basic example. If I wanted to have a lot more metadata, I could have any attribute associated with any image. So in this example, I have not only the file path, file name, but I also have lots of information regarding an object detector. So I have the ground truth, I have the bounding boxes, multiple, obviously, I have prediction. I obviously don't have to have prediction, but in this case, I have both the ground truth as well as prediction. I have grounded truth, bounding boxes coming from the model's output, confidence scores, etc. That allows me to apply a certain query based on any of these columns, any of these attributes, and have a subset of information for from the entire data set. Once I've chosen the relevant part, I can visualize, click on this button, visualize just the chosen images, frames, and what. Now, let's look at a real example. This is the new scenes dataset. It contains about 17,000 images, and we see 3 major clusters. Let's look at them. Night, distinguished from rainy days. natural images of typical driving the dashcam footage. And we have some outliers, some smaller clusters that weren't part of this. As an example, we can look at this one and see that this is a specific case of crosswalks. Immediately, just by the representation, you could find these examples without even having to look for them. Otherwise, you would have to look and sift through thousands upon tens of thousands of images manually, writing scripts. This is the first thing that we can do. Now, the representation and clustering is done automatically. However, sometimes we want to modify that. We can look at the entire dataset and force the system to split it into more clusters. In this case, I start with a 15. I can choose to go to 7 clusters, or I can go to even as high as 50. So let's choose 40 and see that in real time, it's reclustering, rearranging the entire dataset into 40 different clusters. Now, each cluster can be looked at individually. Instead of having 40 different clusters and process them together, I can look at them and choose one cluster. In this case, let's look at the bigger one. And I can split just that into 2 to 4 to whatever number I choose. Once again, that allows me exploration of a certain subset of images, allowing me to clean the data from anything that I don't want to have. And previously, we looked at cleaning based on the metadata, so I could slice based on the metadata. Here, I could clean based on the data itself. So let me just do that. Now, this is done on a set of images. We see here I have 5 results, and we can continue the exploration further and further based on each cluster. This is a representation of an image dataset. In addition, we work with videos just as well. So with videos, we have a notion of the time. We have the order of the images. So this is a different representation of a certain video. Now, here I have about 4 hours worth of footage coming from the Super Bowl, and I can do pretty much the same thing. I can automatically split it into different scenes. I can look at each scene. Let's have a look at the entire dataset. But I can look at each scene. I can look at specific events within that scene. And based on that information, continue maybe with annotation, continue maybe with training for specific tasks. So these are the 2 basic ways the Data Explorer represents data, visual data, either in clustering or versus the time axis. As said previously, that allows us to see immediately the size of each cluster, imbalance between clusters, where we need to add information or maybe where we need to remove it. So that's the first and basic capability of the exploration and visualization of datasets. Now let's look at this example again. So again, I have the new scenes dataset, and let's say that I wanted similar image to a specific image. Let's say I'm looking at this image, and I want to find similar images. So all I do is I click on it, give it a thumbs up, and go to this tab. Now, I've already added a few examples beforehand, but this is the image I just added. So first of all, I can search based on an image or a set of images. We can see here that the night images have a thumbs down. I remove them from the search space. So in real time, I can search based on around 17,000 images. It might as well be hundreds of thousands or millions of images. the results would be equally fast. In addition, sometimes I want to find specific objects, not only based on the image itself. So as you can see, I've marked a few areas here of construction zones. And on this one, let's do it live. I have a grid. So let me mark this cone. You can see the area has been highlighted. And we can do a quick search. Now, obviously, I can continue to refine this, this example, adding more examples, removing things that I don't want to. But this is an amazing way to find specific items from a large data set. Let's look at the results. All the results contain some sort of cones. We start with things that are similar to this, and then we continue to other examples. Using the flashlight, I can look at where the results come from. And interestingly, we can continue that that flow by forcing the system to look outside of that area. How do I do that? I can sample the entire data set. We provide several different sample methods. The core set one will preserve small clusters. And by taking just 5% of the data, I will force the system to look not only where it's comfortable, but everywhere else. So I sampled the data. Now let's look at the search phase. I want it to come from the sample, not the entire data set. And once I did the quick search, I will see where the results come from. My expectation is that the results will come from a much wider spread of locations. And as expected, previously it was focused in one area. Now I get results coming from even the outliers, even from regions far from the original location. This is very useful for dealing with videos or other dense representations of scenes. So with this way, I can build a small data set from a very large, very diverse data set, focusing on specific elements. In this example, if I wanted to detect construction zone events, construction zone sites, and I have a large data set of different of videos or footage coming from dash cams, this is a very simple way, elegant way, and a very quick way. It would have saved me hours, if not days, of finding these examples coming through these different videos manually. So what we've seen, we've looked at the different representation options that Data Explorer provides based on images alone or based on videos. We saw how that allowed it to find outliers, how to find imbalance between clusters, how to find diversity within a cluster. So we can see that this is much denser than this one. And we also saw how we can do an image-based search and even a patch-based search to find specific examples to build a specific data set, specific clean data set. That's it for me for now. Chris, back to you.
All right, Alex, thanks a bunch. Thanks for taking through those features. I think I've got a couple of questions that just popped in that we'll hit, and then we'll wrap this up. One of the questions that came in was around, Alex, the types of images that we support. And I know you showed the videos and then the images, but in terms of the types of images that we support, is there anything that you want to just comment on that?
So this example shows that we support different, very diverse, different types of images. It could be natural, it could be coming from medical industry, or we have example of wafer images, etc. So a very diverse and different range. As far as I see, I haven't seen something that we don't support.
Okay, thank you. Then the other one I got in here has to do with the clustering and the featurizer used to represent those clusters. And the question is, what kind of featurizer do we provide here, and could customers bring their own featurizer?
For the demo purposes and for the built-in functionalities, Data Explorer comes with a featurizer that we developed, trained, and as we can see, it works really well on different types of images. Clients can bring their own. We definitely support bringing your own featurizer. So if you have a specific domain, if you think that the featurizer will work much better on for a certain problem, yes, by all means, you can bring your
own. We got another question coming in here. Which metadata formats are supported? Is the COCO format supported specifically, was the question.
So we can, as we saw here, we can have any metadata associated with an image. And if there is a specific unique metadata format, we can translate. So we can translate it into something that we will be able to ingest automatically. So for example, it could be GPS data or obviously temporal information, but typically we will be able to support anything.
Let's see. I got one in through the chat here. It says, can you train a featurizer from my images? Was what it stated. Go ahead. Yeah.
So we don't necessarily train a featurizer, but first of all, we can see how the built-in featurizer will work on specific images, on a set of images. We will see, we also have several backups, so we can test different options. We can test different options. If we see that the featurizer isn't performing well, we can try to somehow maybe apply some sort of techniques to get a certain featurizer to work well for certain domains. We can try that.
Okay, Alex, thanks. So we're right up at the end of the time. I think we've addressed the questions that have come in. I'd just like to thank everyone for joining us. Keep an eye out. We'll send you a copy of this recording so that you can review it and share it with others. And keep an eye out for a webinar coming up here in about 30 days. And we're going to be doing this on a monthly basis. But Alex, good job, thanks. And I'd like to thank everybody for joining us today. And with that, we will wrap up our session. Have a great rest of your day. Thanks.
Thank you.